Hi, everybody. Mr. Gerhardt here, and we're going to go over question number 12 from the Chapter 2 test in the book. Some people had asked about it, and so we're going to go through it kind of quickly here. The first thing that we're going to do is, one, write down the problem. And the problem gives us this function, f of x equals 3x to the fourth minus 14x squared plus 5x minus 3. So there's our function, and the first thing that they asked us to do is make an appropriate window or graph the function in an appropriate window. And for an appropriate window, we want to have a couple things. I'm just going to jot these down. All right, so an appropriate window, we need to see any and all x and y intercepts. So the x-intercepts are very important because that's where the solution is equal to 0, and the y-intercepts are important because that's where our initial value could be if we put in 0. The other thing we want to see is all local mins and maxes. So we want to make sure that any turning points are visible in our window. And the last thing is we want to see the general shape. And I'll discuss this when we go over to the calculator. So if you have a calculator, go ahead and get it out. And when you click into your window here, you're going to see that I've already entered this in. The one thing you need to make sure of is that when you do a caret or you go into the exponent, that you get out of the exponent to write some other things. Otherwise, you'll have like 4 minus 14x squared all in that exponent, and that's going to be bad. But then when I hit enter, this is my graph. Now, I know sometimes people say, oh, well, just do the zoom out or do the zoom fit. And if I do those, I can come over here and go menu, window. If I do zoom fit, it makes it look like a big parabola. And that gives us some general idea, but also look at how big this y value is, 31,514. So that's not very good in what we were looking to do. So I'm going to go back to our standard windows. Same thing with the zoom out. If you go menu, zoom out, and then you just say, okay, well, I'm going to zoom out here, it doesn't give me a very good window, and I can't tell a lot of what's happening. So go back to your standard window. And look at this. We know that it's an x to the fourth graph, and that means that it's both ends are going to be going up because it's got a positive leading coefficient. We can also see that there's some sort of bend here, and there's probably a bend down here and a bend down here. So we got to make some adjustments. We also know that it doesn't go much further than 10 and negative 10 in what we're interested in, so I can make some adjustments. So I'm going to go window, and I'm going to go in my window settings. And I'm actually going to go from -5 to 5 on the x because it doesn't look like it's getting much wider than that in the area that we're talking about. And I'm going to say maybe go down to -20 and up to 10. And I'm just guessing because based on what I saw, I thought it might go down to -20 and 10. And you can see, now I can see there's a curve here, and here's a local min, here's our local max, but -20 wasn't enough. And so I'm going to go down even further. That's our Y minimum. So I'm going to go to our window settings, and I'm going to make our Y min -35, just to be on the safe side. I could also bring my X min and X max in a little tighter, but it's not important. I know it's going to keep going on forever in both directions because our domain is all real numbers, but I don't need to show all the way out here at 10 and -10 because this gives me a good shape and it fits the window. So I can see my x-intercepts here and here. I can see my y-intercept here. I can see my local max, my local mins, and I can tell the general shape of the graph, and it's not in one little part of the window. So this would be a good window. Could you have something different? Sure, you could, but this is what I'm going to use, and this is what's going to work for me. So that's the first thing. The second question is this graph one-to-one? And I'm going to say, no, it's not. The reason it's not is because if I were to draw a horizontal line here, let me say like y equals -5, you can see right here, y equals -5 is this green line, and it intersects the red graph 4 times. And because it intersects the red graph 4 times, it means that for y equals -5, we have 4 different x values that could give us that. That, by definition, is not one-to-one. Our graph fails the horizontal line test and therefore not 1-to-1. So I'm going to go back and delete that because I don't want that in there anymore. But now I know that it's not 1-to-1. The next thing is what are our local maxes and mins? And in the Inspire, it's actually pretty easy to do. You would go to Analyze Graph, and you're looking for maximums and minimums. So I'm going to say maximum, click to the left and to the right. It's asking for the lower bound and upper bound, and it wants us to round to 2 decimal places. So I would say 0.18 and negative 2.55 would be our maximum. Now, this isn't the maximum for the whole graph because it keeps going up forever on both ends here, but this is our local maximum. And so in this area, that's the highest point that it reaches. It's also a turning point where the graph was increasing and now it's decreasing. I also want to find these minimums. So I'm going to go Analyze Graph Minimum. It's asking for the lower bound. Lower bound means to the left of the minimum. Upper bound means to the right. And there's our point. I'm going to slide that over just so it's out of the way a little bit. I'm going to do the other minimum as well. Analyze Graph Minimum, lower bound, upper bound, and there's our minimum. So if I were to flip this back over and look at this, I can easily say that it's not 1-to-1 because it fails our horizontal line test, HLT. For part C, it was asking for local mins and maxes. Our max was 0.18. That's the X value. The Y value is negative 2.55. This is the maximum value. This is the X value where it occurs. For the minimum, we had 2 local minimums. The first one was negative 1.61 and negative 27.18. That's our lowest minimum. That's the minimum for the whole graph, actually. And then we have 1.43 and negative 11.93. We're putting these in parentheses because these are all points on the graph. And we don't worry about including or not including. We put them in parentheses because of that. For part D, it's asking for domain. Now, if I flip back over here, I know that this graph's going to keep going up and to the left forever. I also know it's going to keep going up and to the right forever because I know my parent function of x to the 4th looks like a big parabola. And so it's going to keep going up to the left forever, up to the right forever. We're also not dividing. We're not square rooting or even rooting. And so I know my domain is all real numbers, or negative infinity to infinity. The range, I'm going to look at the graph and I'm going to say, well, what's my lowest y value? And you can tell there's no y values down here, but this is my lowest y value, this minimum point, which is negative 27.18. So I'm going to say, yep, that's included. So negative 27.18. And then I need to know, when does it stop going up? Well, because of my knowledge of polynomial functions and graphs and parent functions, I know it keeps going up forever here, keeps going up forever here, and therefore it's never going to stop going up. And my maximum y value is going to be infinity. And we never include infinity. We always use the parentheses there. So negative 27.18, including all the way up to infinity, is our range. And then the last part is asking us for increasing and decreasing. So I'm going to click back over here. And increasing means we have a positive slope. And if I'm looking here, I'm working from left to right. This part of the graph, from here all the way to this minimum value, the graph is decreasing. If I were walking along, I'd be sliding down this hill. And then I get to the bottom of the hill, and then I have to walk back up. When I'm walking back up, that's when the graph is increasing. And I'm increasing from negative 1.61 all the way up here to 0.18. Those are the x values of where I'm increasing. And then I slide down this hill, decreasing from 0.18 to 1.42 or 1.43. And then I got to start walking back up the hill again. So I'm going to go over here and I'm going to say I'm increasing, INC, short for increasing, from negative 1.61 to 0.18. Those are the X values where the graph is increasing. I'm also increasing from 1.43 to infinity. And so again, when we describe increasing, decreasing, we use our X values. Now decreasing was when I was sliding down the hill. I was sliding down the hill from negative infinity until negative 1.61. And then I was also sliding down the hill from 0.18 to 1.43. And if you look, these X values, these are all X's, X and X and X, they're the X values of our turning points or our maxes and mins. There's the negative 1.61, there's the 1.43, and there's the 0.18. And those are the values that we use here, and here, and here, and here, and here, and here. And so those are what we're looking for. That's why it's helpful to identify the maxes and the mins before we do increasing and decreasing intervals. So I hope that helped out, and we'll have more to come.